Alright guys, I'm going to get through this really quickly. We are doing absolute value equations. I did a few of these. I did not do all of them. I want you to do some of them on your own. So that's why I didn't do all of them. If you want to come check your answers in the morning before school or between classes, feel free. Okay? This is lesson 2-1 on absolute value equations. Alright, I did number 3 first. Number 3 was t plus 5 equals 8. Absolute value of t plus 5 equals 8. Remember, we're going to work these out on a t-chart. We're working inside the absolute value bars. That's why we don't have the absolute value bars written down. The equation is t plus 5. That needs to be equal to negative 8 and positive 8. So on the negative 8 side, we're going to put t plus 5 is equal to negative 8. Subtract 5 from both sides, we get t is negative 13. Then we do t plus 5 is equal to positive 8. We subtract 5 from each side, and we get t is equal to 3. Now the instructions also tell us to graph the solution. They weren't written down there. I told you to write them in. So we will graph these out, and we will mark negative 13 and 3. Okie doke. Next, we did number 7. That is 11 times the absolute value of x minus 8 minus 7 equals 48. This is one that we have to strip everything off from around the absolute value bars before we can set things equal to the positive and negative side. Okay, so we started with adding 7 to both sides, and then we divide by 11. That gives us the absolute value of x minus 8 is equal to 5. Okay, I'm going to set that up in my t-chart. We'll do x minus 8 is equal to negative 5, and x minus 8 is equal to positive 5. We'll add 8 to both sides, and we get x equals 3. Do the same thing on the other side, and we get x is equal to 13. Graphing that out, make sure you show your 0. We will graph the points 13 and 3. Okay. Number 8. This is one of the advanced questions for the regular students. We've got the absolute value of 6x plus 7 divided by 2 is equal to 3. We'll set up our t-chart for one side being equal to negative 3, one side equal to positive 3. We're going to multiply both sides by 2, and we're going to do that on both sides of the t-chart. That'll give us 6x plus 7 is negative 6, and 6x plus 7 is positive 6. Subtract 7 all the way across the board. We get 6x is negative 13, and 6x is negative 1. Divide by 6 all the way across the board. We end up with x is negative 13/6, and x is negative 1/6. Graph that out. Remember, I said I wanted you to show me 0, and then I wanted you to show me if we had a fraction, I want you to show me the whole numbers on either side of the fraction. So we're going to see 0, 1, 2, and 3 for our major lines. Then I will have a line for the negative 1/6 and a line for the negative 13/6, and we will put dots on both of those. Alright. Now, this next part, we are going to solve the equation and check for extraneous solutions. We're going to do number 9 and number 13. Number 9 is the absolute value of x plus 5 is equal to 3x minus 7. We'll set up our t-chart, and we'll do the negative side and the positive side. So the negative side has x plus 5 is equal to negative 1 times 3x minus 7. And then x plus 5 equals 3x minus 7 on the positive side. We distribute the negative through the binomial, and we get x plus 5 is negative 3x plus 7. I'm going to add 3x to both sides and subtract 5. That gives me 4x equals 2. Divide by 4, so x is 0.5. On the positive side, we're going to subtract x and add 7. That ends up giving me 12 is equal to 2x. Divide by 2, and x is equal to 6. Now I need to check my work for the extraneous solutions. So I start by taking my original equation, and I plug in 0.5 for x. Slow this down just a little bit. So we have 0.5, the absolute value of 0.5 times 5 is equal to 3 times 0.5 minus 7. So the absolute value of 5.5 is equal to 1.5 minus 7. So we have 5.5, the absolute value of 5.5 is 5.5, is equal to negative 5.5. That is not a true statement, so 0.5 is an extraneous solution. Now we're going to see about x equals 6. So I take the absolute value of 6 plus 5 and set that equal to 3 times 6 minus 7. I end up with the absolute value of 11 is equal to 18 minus 7. The absolute value of 11 is 11. 18 minus 7 is 11. So 11 equals 11 is a true statement. So 6 equals x is our solution. Alrighty. Number 13. This one we're going to end up finding is a little bit different. Okay? Generally we do have a solution, but there is always that rare occasion where we may not. We've got the absolute value of 3x minus 5 plus 4 equals 1. Again, we need to strip off everything around the absolute value bars first, so we subtract the 4. That gives me the absolute value of 3x minus 5 is equal to negative 3. Okay, set up my t-chart. I'll have my negative and positive side. So I have 3x minus 5 is equal to negative 3. That becomes positive. And 3x minus 5 is equal to negative 3. Positive negative 3, if you will. We add 5 to both sides. We'll go ahead and do that all the way across the board. And we get 3x is equal to 8. And 3x is equal to 2. I'm going to divide by 3 across the board. And I have x is 8/3 or x is 2/3. Okay, now I'm going to plug our answers into our original equation. So I have the absolute value of 3 times 8/3 minus 5 plus 4 equals 1. My 8/3 times 3, my 3's cancel each other out or reduce out. So I'm left with 8 minus 5 plus 4 equals 1. The absolute value of 8 plus 8 minus 5 is 3 plus 4. So the absolute value of 3 is 3. 3 plus 4 is 7. 7 equals 1 is a false statement, so that is an extraneous solution. Now do 3 times the absolute value of 3 times 2/3 minus 5. That gives me the absolute value of 2 minus 5 plus 4 equals 1. Or the absolute value of negative 3 plus 4 equals 1. The absolute value of 3 is 3 plus 4 is 7. 7 does not equal 1. That is a false statement. So 2/3 is also an extraneous solution. So this is one of those rare cases where we have no solution. Alright, let's do number 17. We are looking at graphs. We are to write the absolute value equation for the graph. Okay? We're going to do number 17, which has points at 2 and 6. Now, I'm going to start by looking at the distance between the points. Okay? To find the distance between the points, we're going to do 0.2 minus 0.1. Okay? And then the distance to the center between the points is from either point is going to be 0.2 minus 0.1 divided by 2. Because it's halfway between, so we divide by 2. So the center is, we're just going to go ahead and use 0.2. 0.2 minus 0.2 minus 0.1 divided by 2. Or 0.2 minus that distance to the center. So we have 0.2 is 6, minus 0.1 is 2, and that's 4. So the distance to the center from either point divided by 2 is 2. So in order to find my center, I'm going to take 0.2, which is 6, divide it by the distance to the center, or subtract the distance to the center, which is 2, and that will give me 4. Okay? So my equation, the way I'm going to write this out, is the absolute value of x minus the center is equal to the distance from the center to a point, which is 0.2 minus 0.1 divided by 2. So that gives me the absolute value of x minus, my center is 4, is equal to the distance to the center is 2. If I want to check that, make sure that that works. Okay, 0.1 would be, we'd plug in 6 for 0.2, excuse me. 6 minus 4, the absolute value of 6 minus 4 is 2. The absolute value of 2 is 2, so 2 equals 2, that's a true statement. Then we try the other side. Use 0.1 for x. Absolute value of 2 minus 4 is equal to 2. 2 minus 4 is negative 2, so the absolute value of negative 2 is 2. 2 equals 2, yes, so that does work. Number 18. We have points at 25 and at 45. Okay, the distance between the two, 45 minus 25 is 20. Divide that by 2. That gives us a distance between a point and the center as 10. So I'm going to take point 2, subtract that 10, and find my center at 35. So my equation is going to be x minus 35 is equal to 10. If I want to check that, put in point 2 for x. 45 minus 35 gives me an absolute value of 10 equals 10. Absolute value of 10 is 10, so 10 equals 10 is a true statement. Then we use point 1 for x. 25 minus 35 gives me an absolute value of negative 10 equals 10. The absolute value of negative 10 is positive 10, so 10 equals 10 is a true statement. Alright, 2 more here. Number 20, we're just going to solve these and then graph the solutions. We're not checking for extraneous solutions here, even though there are variables on both sides. We're just going to plug them in, get what are possible solutions, and graph them. Okay, so we have 4 minus 3m is equal to negative m plus 10. So that's negative m minus 10. Add 3m. Add 10. I get 14 is equal to 2m. Divide by 2. M is equal to 7. On the positive side, I'm going to add 3m and subtract 10. I'm going to get negative 6 is equal to 4m. I'll divide that by 4. So m is equal to negative 3/2. Graph that out. There's my 0, my 1, and my 2. And my negative 7. Halfway between 1 and 2, negative 1 and negative 2 is negative 3/2. So I put my points at negative 3/2 and negative 7. Number 23, last one. Absolute value of 5p plus 3 minus 4 equals 2p. Add 4 to both sides so that we have absolute value of 5p plus 3 is equal to 2p plus 4. Set up my t-chart. 5p plus 3 on the negative side is equal to negative 2p plus 4, which when I distribute that negative will change my signs in the binomial. On the positive side, I have 5p plus 3 is 2p plus 4. Distribute my negative 1 through my binomial. I have 5p plus 3 is negative 2p minus 4. Add 2p to both sides. Subtract 3. I get 7p is equal to negative 7 divided by 7. P is equal to negative 1. On the positive side, subtract p from both sides. Subtract 3. I get 3p is equal to 1. Divide by 3. And p is equal to 1/3. Okay. Graph those out. And I put a point at negative 1 and positive 1/3. Alright. That should about do it for tonight. I'm going to go post this. And y'all have a good night. I'll see you in the morning.